Hello everyone. Today's PowerPoint is about oxygen-enhanced bioremediation. Well, let's first discuss what bioremediation is. Essentially, it's enhancing the degradation of a contaminant in groundwater or the soil by providing it nutrients, electron acceptors, or microorganisms. Oxygen-enhanced bioremediation techniques can be divided into three parts: air sparging, hydrogen peroxide, and nitrate enhancement. Air sparging is the injection of oxygen below the water table to increase oxygen concentration, which in turn degrades the contaminant. Hydrogen peroxide does the same thing as air sparging. It increases the oxygen concentration because it's oxygen rich, and it degrades the contaminant. And finally, nitrate enhancement is the anaerobic degradation of a contaminant through the use of nitrate, which is an electron acceptor, and enhances the degradation of a contaminant. The applicability of oxygen-enhanced bioremediation is for non-halogenated volatile organic compounds, semi-volatile organic compounds, fuels, and nitrate has been used to treat benzene, toluene, ethylbenzene, and xylene, or otherwise referred to as BTEX. Some limitations associated with oxygen-enhanced bioremediation is that it heavily depends on the heterogeneity of the subsurface. The lower the heterogeneity, or in other words, homogeneity, allows for faster delivery of the degraders to the contaminants. Nitrate is heavily regulated in drinking water in many states and is banned for remediation purposes. Other treatment methods, such as carbon adsorption, may still be necessary to completely degrade the contaminant in groundwater or the soil. And finally, bacteria may actually end up using the oxygen that you inject or the nitrate that you inject instead of that being used to degrade the contaminant that you're targeting. This is a typical picture of what a oxygen-enhanced bioremediation looks like. You've got a well where you can inject oxygen below the water table, the dash line, and that oxygen travels to the regions where the contaminant exists. Here we can also see another well existing which sucks up the water for further treatment such as carbon adsorption. So the pros for using oxygen-enhanced bioremediation is that it's good for remediating BTEX, fuels, volatile and semi-volatile compounds, and its cons are that nitrate is heavily regulated, further treatment of groundwater may still be necessary, and it's quite costly. Some of the costs associated with the different methods of oxygen-enhanced bioremediation is anywhere between 10 to $600, with the cheapest being air sparging and hydrogen peroxide being 10 times more expensive than either nitrate enhancement or air sparging. The references I used for this presentation are Remediation Technologies, Screening Matrix, and Reference Guide, version 4. Thank you for listening. Everyone,